This video is on solving systems of linear inequalities. We solve systems of linear inequalities by graphing. So the solution to a system of inequalities is the overlapping shaded regions of multiple linear inequalities. There are two types of solution possibilities. We have intersecting regions where the overlapping shaded region is the solution, so where both shaded regions hit. Or we have separate regions where no solution exists. So to find the region, we have to put all the inequalities in slope-intercept form, being careful of dividing and multiplying by negatives, because when we're dealing with inequalities, you might have to flip the inequality. We'll then graph the inequality, being careful of dotted or solid lines. Then we're going to shade each inequality in the proper direction, and then we'll shade the overlapping region, so the solution set darker. We'll even highlight that location. So in order to do this, we're just going to graph them individually and shade them individually. So we're going to find the solution set for the system of linear inequalities, and then we're going to determine if the coordinate 2, 7 is part of the solution set. So our first example, we have to put it as x, y. We want to graph x is greater than or equal to 2. Since this is one variable, this is going to be either a vertical or a horizontal line. This I'm going to graph in pink. This will be a vertical line at positive 2. Now, since this is a greater than or equal to, this is going to be a solid line at x equals 2. I'm going to wait to shade because I want to make sure I can see both of my lines. So I'm going to use different colors to represent my lines. My second one, I'm going to graph in blue. It's going to be y is greater than 3. Again, since this is just one variable, it's going to be either vertical or horizontal. It's going to be at a y value, so that means I'm going to have a horizontal line. I go to positive 3. It's going to be a horizontal line at y equals positive 3. But since this is just greater than, it's going to be a dotted line at positive 3. Now that I have both lines graphed, I can go back to the different colors and I can shade them appropriately. So I have graphed the inequality, being careful of dotted and solid lines. Now I need to shade. So my x is greater than or equal to 2, so my pink line, I need to be greater than 2. So that's going to go towards the right. So I'm going to shade towards the right. For my blue line of y is greater than 3, so greater than 3 is going to be more than 3, so I'm going to shade up from that blue line. So I need to find the location at which they intersect, so the graphs, the shading intersect. I can see where the blue and pink both meet. That's my solution set. So I can see that along this line and this dotted line, so that means that the dotted line does not incorporate all of that. This is my shaded region because the pink and blue intersect here. I will highlight this section as well because this is my solution. Now we're going to look for the coordinate of 2, 7. 2, 1, 2, 3, 4, 5, 6, 7 is located here. Since 2, 7 is on one of the lines, I have to make sure that it actually works. 2 is x, so 2 is greater than or equal to 2. That is correct. That does work because 2 is equal to 2, so it works. The y is 7, so 7 is greater than 3. It does work. Therefore, 2, 7 is part of the solution. 2, 7 is part of the solution. The coordinate is on the solid line, therefore it is incorporated in the solution. Our second example, we want to make sure our inequalities are in slope-intercept form, which it is because y is by itself, so we don't have to worry about dividing by a negative. we need to graph each individual line. So I'm going to use pink and blue again. So for my first line, I'm going to do it in pink. It's going to be my 2 minus x, so my y-intercept is 0, 2, and I have a slope of -1. So I'm going to change an y of -1, change an x of +1. And now I have my pattern. So down 1, right 1. I'm going to keep going until I can't go any further. I'm going to go in the opposite direction as well, up 1 and left 1, because that's a change in positive y, and then a change in negative x, which is still a negative slope. Now, since it's just less than, I'm going to keep it as a dotted line. So I'm going to connect every other so that you can see the dashes. I'm going to wait to shade until I have graphed my blue line. So for the blue line, our first coordinate is 0, 4. 1, 2, 3, 4. And our slope is +1. So change in y of positive, change in x of +1. And now I have my pattern. I'm going to keep going until I cannot go any further. And since this is just a greater than, not equal to, it's going to be a dashed line or a dotted line. So I'm going to connect every other coordinate so I can have the dashes in there. Now that I have them both graphed, I can go back and shade. So for the pink line, for y is less than, I'm going to go onto my pink. I'm going to shade down because it says less than. That tells me that this is the section I'm going to shade in pink. Then I'll go to my blue line, and it says greater than. So I'm going to go on my blue, I'm going to shade up. So all the way along my blue, I'll shade up. Now I find the location of where both the blue and pink meet, which is in this section over here. All along here, even up here, even though it doesn't look like the blue's up there, it's just because I didn't put the blue as far up. But all of this is our solution. So I'm going to use a highlighter on here to show that all of this is part of the solution. And it does keep going. So then I look for that coordinate of 2, 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. 2, 7 is in this spot over here, which is in the blue, but it is not in the highlighted yellow. So it would work for the second equation, for the second inequality, but it would not work for the first inequality. Therefore, 2, 7 is not part of the solution set. We can also check it by plugging in 2, 7 into the inequalities. So I'm just going to write this out as 7 is less than 2 minus 2. 7 is less than 0. This is false. It did not work for the pink, and we knew that because it only worked for the blue. But if it's false for any part of it, it's automatically false. That's how we can automatically know if it does work or not. We could actually plug the coordinate into the inequality as is and see if it's a true or false statement.